All right, homework problem number 3 for Coulomb's law. We can write this as, well, let's just write down Coulomb's law right here. F equals K with the absolute value of Q1 and Q2 all over R squared. And in this problem, we have particle 1, Q1 with this value, and particle 2, Q2 with this value. So we can write Q1, Q2, and we have an unknown value of Q3. Q1 is 1 times 10 to the negative 6. Q2 is negative 2.9 times 10 to the negative 6. And Q3 is unknown. We have a length L here of 17 centimeters, and then a unknown length to the left of particle 1 here, which we can call R. So those are our two unknowns, and we are also told that the net electrostatic force from particles 1 and 2 is 0 with particle 3 located somewhere where we don't know. So because they have a net charge of 0 with particle 3, we can say that K of Q1 and Q3 all over R squared equals K of Q2 and Q3 all over R plus L. Because Q3 is all the way over here, it is not just this unknown distance, it's this unknown distance from 3 to 1 plus all of the distance of 1 to 2, which we do know. We can then simplify this because we have K on both sides and Q3 on both sides. We can simplify this to just Q1 over R squared equals Q2 over R plus L squared. And then plugging in those values, we get 1 times 10 to the negative 6 all over R squared equaling negative, or actually because it's absolute value, it would just be 2.9 times 10 to the negative 6 all over R plus L squared, and we have 10 to the 6 on both sides, so that also can be canceled out. And this is going to give us 1 over R squared equaling 2.9 over R plus L squared, and square rooting both sides, we then get 1 over R equals the square root of 2.9 over R plus L. And then if you cross multiply these, you're going to get the R square root 2.9, or what we could say right here instead, let's say square root, erasers on, square root 2.9 R equals R plus 17, which we just subtract R from both sides, square root 2.9 R minus R equals 17. We can take R outside of this equation. 2.9 minus 1. And can say that that equals 17. And then dividing both sides by the square root of 2.9 minus 1, we get 17, or we get r equals 17 over square root of 2.9 minus 1, which is roughly equal to 24.2. And this is going to be our distance x to the left of particle 1. Because they said to the left of particle 1, we can keep it as 24.2. If they didn't say that, we could say that x equals negative 24.2. And the distance y is going to remain 0. It's not going to be up or down. It's going to be directly along the x-axis. So that is the answers for this problem.